Hi. In this lesson, we're going to work with how to solve for a variable. Now, this lesson may look very similar to a lesson that we've done in the past, which was solving multi-step equations. That's because the rules that we're going to be using to isolate a variable is going to be similar to the one that we did in that lesson. But the letters that we're going to try to isolate today are equations that you've worked with in the past, such as volume, circumference, area. Those equations are where we're going to work for in this lesson. So you ready? Let's begin. In the past, we said if you want to solve for a variable, the first thing you want to do is you want to get rid of any fractions that you see. You don't always have to get rid of the fractions, but sometimes it's easier to get rid of the part that you don't like the most, which are the fractions. Step two, if we're able to distribute, let's distribute. Because distributing is going to eliminate the parentheses that allows us to technically work with our next step, which is getting rid of the term that's being added or subtracted. And then your last step, step four, was let's multiply or divide, depending on what you did in step one, to the final letter that you have. So what's next to the letter that you have? Let's do the inverse, which is multiplication and addition. Multiplication and division. Okay, so for example one says if d is equal to r times t, then solve for t. How do we do this? The first thing you're going to notice is t is right here, and it's next to r, rt. That technically means it's being multiplied. So we have to ask ourselves, we're going to try to get t by itself. What is the inverse? What is the opposite of r times t? It should be dividing. Dividing by what letter? The letter that's next to the t that you're solving for, which is r. So I'm going to go ahead and divide both sides by r, and I'm going to get d over r is equal to t. And that's my final answer. And that's how you solve for your first variable. Okay? You're going to notice I didn't have to do step one. There wasn't any fractions. I didn't have to do step two. There wasn't any parentheses. And I didn't have to do step three because there wasn't any term being added or subtracted next to the variable that I was solving for. So we went ahead and jumped straight to step four, which was let's get rid of the r by doing the inverse, which is division. Okay? All right, so in example two, you're going to read it. It says if x is equal to t over p, then solve for p. The first thing you want to ask yourself is where is p? P happens to be in my denominator. So what do? Look at step one. Step one says get rid of the fractions. I'm going to do that. If I can get rid of something that I don't like, I'm going to make my life a little bit easier when it comes to solving for this variable. So I'm going to go ahead and divide. Instead of dividing by p, I'm going to go ahead and do the opposite, which is the inverse. I'm going to multiply by p. Now, when I write this out, on the left side, I'm going to have p times x. Normally, you want to write this in alphabetical order. P comes before x in the alphabet, so I'm going to write it as px. On the right side, the p is going to cancel out because they're technically the inverse of one another. I'm going to be left with t on the right-hand side. Now, the problem is I'm still trying to solve for p. P and x are together. What's happening to p and x? There are no parentheses, so I won't distribute. There is no term being added or subtracted, so I'm going to go straight to my last step. What's the inverse of p times x? It's p divided by x, right? So I'm going to go ahead and divide by x to both sides. When I divide by x to both sides, the x's are going to cancel on the left, and I'm going to be left with p is equal to t over x. And that's my final answer. I isolated p and got it by itself. Okay? In example 5, it says if x minus 3y is equal to b, then solve for y. Notice y is next to negative 3, so that's the piece that I'm going to keep to the end. There aren't any fractions, there aren't any parentheses. There's only a term being added or subtracted. Be careful with this one, because you're going to notice the placement of the variables may make you do something that you're not supposed to do. So I have to isolate negative 3y because it's all together. So I'm going to get rid of the x. You'll notice that x is technically being positive. X is positive. So because it's positive, I'm going to subtract x to both sides. On the left-hand side, the x's are going to cancel out nicely, and I'm left with negative 3y because that's all going to drop. On the right-hand side, I'm going to be left with b minus x. I can't combine them because they're not similar terms. They don't look alike. They're two different letters. So I can't combine two different letters, so I write it in that order. Now, my last step is, what am I going to do? I want to isolate y. What's next to y? The negative 3. It's being multiplied to y. So what's the inverse of negative 3y? I'm going to divide by negative 3. And I'm going to do that to both sides. And if I do that to both sides, what's going to happen? My final answer is the negative 3's are going to cancel out, and I'm left with y equals b minus x divided by negative 3. And that's my final answer. You'll notice that I did get y by itself, and that's exactly what I wanted to do. I wanted to isolate the y. Okay? All right. So we're going to try example 4. If you want to start this problem on your own, pause the video, try it on your own. Okay. If 5x plus 10y is equal to b, then solve for x. So what am I going to do? My first step is Let's figure out the letter that I'm solving for. I'm solving for x. X is right here next to 5, so that's the letter and the number that I'm going to keep till the end. I have to get rid of everything else that's next to it. There's a plus 10y. So what's the inverse of adding 10? It's going to be subtracting 10. So I'm going to subtract 10 to both sides. On the left side, the 5x is going to drop down. I'm going to be left with 5x. 10y's are going to cancel. And I'm left with b minus 10y. Now, I wish I was done, but I'm not, because why? There's still a letter next to 5. That's the x that I'm solving for. There's a 5 there. So I have to get rid of the 5. 5 and x are being multiplied. So what's the inverse of multiplication? Division. So I'm going to go ahead and divide by 5 to both sides. And my final answer is going to be x is equal to b minus 10y over b minus 10y over 5. And that's my final answer. B minus 10y over 5. And that's how I isolate x. Okay. So what we're going to do now is we're going to go ahead and solve for our last problem. Example 5. You're going to notice there's a lot of more steps in this problem. So it's all about sticking to the basics. What are our rules? If x is equal to t minus 4q over p, then t is equal to what? You'll notice t is right here. So I have to do everything in my power to get t by itself. Step 1 is get rid of the fractions. So instead of dividing by p, I'm going to go ahead and multiply p to both sides. Now if I multiply both sides, p times x is going to be px on the left. On the right-hand side, the p's are going to cancel out nicely because they're inverses of one another. I'm left with t minus 4q. I want to isolate the t. So I have to ask myself, what is next to t? It's a negative 4q. So what's the inverse of negative 4q? I'm going to go ahead and I'm going to add 4q to both sides. Now, when I add 4q to the left side, I really can't combine px and 4q. They're two different terms. So what am I going to do? I'm going to write them next to each other. Px plus 4q. And on the right-hand side, the t is going to drop down, and the negative 4q and the positive 4q are going to cancel, which means I finally got t by itself, and that's my final answer. If there was a number next to t, I would try to divide it. But because t is just by itself, that's all I have to do. So in this section, in this lesson, we're solving for complex variables within a problem that has multiple variables. But treat it exactly how you'd be treating this if you were solving multi-step equations. Okay? So I appreciate you watching. Hopefully this helped, and I'll see you next time.